Here. So last week when I saw you, we were using the quadratic formula to solve quadratics, right? Which was like the pinnacle of the whole unit, was to learn the quadratic formula, right? Today we are talking about graphing quadratic equations. And we're doing it a very specific way. A couple things to know when you're graphing a quadratic. If you have, when graphing, that is supposed to be a G, not a Q. When graphing a quadratic, in the form ax squared plus, could be plus or minus bx, plus or minus c, what you want to understand is if this a is positive, it's going to graph up, right? Now this is just the standard where I started at 0, 0, but that could be anywhere on this graph. But what you know is if this a is positive, we are graphing up. If a is negative, if I have minus ax squared plus or minus bx plus or minus c, that graph is going to go down, right? And again, it could start anywhere on this graph. I just know that if it's negative, it's going to point down. If it's positive, it's going to point up. The next thing you need to know is that quadratic equations are symmetric. They have symmetry. And that means that what happens on one side is happening on the other. When we say that they're symmetric about the axis of symmetry. And the axis of symmetry is really just this line. Like in this case, the axis of symmetry on them would be this y-axis, right? That divides them in half. And what it means to have an axis of symmetry is it says that if we fold that graph on that line, that symmetric line, that both sides should line up perfectly, right? Because they're symmetric, and that would be that middle point, and everything should match. To find the axis of symmetry, we use minus b over 2a, and that'll give us that middle point. The other thing that's new that we would have to find would be the vertex. To find the vertex, well, the vertex is just a point, and the vertex is a point that is our maximum or minimum of the graph. And if we look at this, if I'm looking at this purple parabola right here, the vertex is going to be this point here at 0, 0. It is the lowest point in the graph. It is our minimum, right? If we have a negative, it's also going to be at 0, 0 in this case, because that would be our maximum. It would be our highest point, right? So our vertex is our maximums and our minimums. And the way we find them is that they're always on the axis of symmetry. So the x value is always going to be that minus b over 2a. And once we find what that is, we plug it in for x into the equation, and it'll give us the y value, right? So we want to know what y is when x is minus b over 2a. If we were to write that in proper notation, it would be like f of x, f of minus b of 2a. right? I would write that like that, minus b over 2a. Do you need to know that? No, because I'm going to show you how it all works. But these are the 3 pieces of information that we need to have in making this graph. All of your homework problems are going to state to do things the exact same way. You need to solve using the quadratic formula to find your x values. Then you need to find the axis of symmetry in the vertex, and then you will need to sketch a graph. All 4 problems ask you the same thing. And so we are just going to go ahead and do some problems. So we are going to start by looking at example 1, because, well, why would we start by looking at example 3? We'll go x squared minus 8x plus 16 equals 25. Now, the first thing we have to do is solve this using the quadratic formula. So I need to subtract 25 from both sides, because remember, we have to set it up equal to 0. And I will get x squared minus 8x minus 9 equals 0. And now I can go ahead and solve this using our quadratic formula, which, if you remember, was x equals minus b plus or minus b squared minus 4ac over 2a. And we just need to plug these in. So we know that a equals 1, b equals negative 8, and c equals negative 9. And so we can just plug those numbers into the formula now. So I'm going to go x equals minus 8. Well, minus 8, right? Plus or minus b squared. Well, that's just negative 8 squared. Minus 4 times a, which is 1, and c, which is negative 9, all over 2 times a, 2 times 1. And so we're just going to slow solve this, one piece at a time, right? Well, negative times negative 8 is just positive 8, plus or minus, and we're going to go with what's under this. Negative 8 squared, that is 64. Negative 4 times 1 is just negative 4. Negative 4 times negative 9 is positive 36, all over 2. 64 plus 36 is 100. So I have 8 plus or minus the square root of 100 over 2. What is the square root of 100? Yes, sir. So we have 8 plus or minus 10 over 2. And that's going to give us 2 solutions, right? It's going to give us 8 plus 10 over 2, right? We've got 8 plus 10 over 2 is one of them. And the other one is going to be 8 minus 10 over 2. 8 plus 10 is 18 divided by 2, which is 9. 8 minus 10 is negative 2 divided by 2, which is negative 1. Those are our 2 x values. We're going to leave them here for right now, and we are going to go and find our axis of symmetry, right? Our AOS, which we know is minus b over 2a, right? Minus b is minus negative 8 over 2 times a, which is just 1. So that gives me 8 over 2, which is just 4. So I found my axis of symmetry now, and I have to find my vertex. And the way I find my vertex is, we know that the x value of my vertex is just the axis of symmetry. How do you suppose I find the y value? Any guesses? $1 million guesses as to how I would find out what the y value of that vertex is. It's a really good thing none of you know, because I don't have $1 million. You guys probably know, and you just weren't answering because you knew I didn't have $1 million. You're trying to help a sister out. The way we would find out what the y value of the vertex is we're going to plug in the x value into x and solve, right? So I'm going to write this as x squared minus 8x minus 9 equals y. And we need to find out what that y is. And the way we're going to do it is, since we know what the x is, we're just going to solve. I'm going to go, okay, I have 4 squared minus 8 times 4 minus 9 equals y. 4 squared is 16 minus 8 times 4, which is 32, minus 9 equals y. 16 minus 32 is negative 16. Minus 9 is negative 25. And so this is our vertex. Now I'm going to show you how easy it is to sketch just knowing these things, right? Because I'm not asking you for super accurate graphs, right? I just said sketch them. Doesn't have to be super accurate. So here I've got my XY axis, right? This is my X, this is my Y. I know that I have a point on the X axis at -1, and I know that I have a point on the X axis at 9. I don't have to draw every single point. I know that at 4, which I'll call this 4, right, which is between them, I have my axis. Oops, can't make a straight line to save my life right now. Right, I have my axis of symmetry. The other thing I know is that on this axis of symmetry at 4, -25, I have another point, right? And that point is my vertex. Now all I have to do is connect. I don't need to create anything extravagant, right? That's good enough. Granted, it should look more you-like, but, you know, I'm drawing on a tablet here. So does that make a little bit of sense to you? I've got more examples for you so that you're not just left with that example, but does it make some sense? Do you feel it? I got one yes. I'm going to assume everybody else agrees with Alfonso. All right. Let's do one more example, at least. Let's do x squared plus 6x plus 3 equals y, right? I could set it equal to 0. When I go to solve the quadratic, I'm going to want to set it equal to 0, not y, because that's what using the quadratic formula is, right? We want to know what it is when y equals 0, and it sits right on that x-axis. So the first thing that we need to do is we need to determine what our a is, which is 1. Our b is 6, and our c is 3. And so when I go to solve, I'm just going to have this mentally set equal to 0. And we can plug it in. We can go x equals minus b. Well, minus b, let me write it up here for you. X equals minus b plus or minus b squared minus 4ac over 2a. So we know our b is 6. So we're going to minus 6 plus or minus 6 squared minus 4 times a, which is 1, and c, which is 3. I like this problem because the numbers are nice and simple for us. All over 2 times a, which is just 1. And then we're going to start solving these. Right, well, we've got minus 6, which we're going to leave alone, plus or minus. 6 squared is just 36. Negative 4 times 1 is negative 4 times 3 is negative 12. I feel like this isn't going to give me pretty round answers, but I don't need pretty round answers. 36 minus 12 is going to be 24. So I have minus 6 plus or minus the square root of 24. 24 is not a perfect square, but it is okay. We don't need it to be a perfect square because we're only doing sketches of graphs. We're not doing exact graphs. So I do need to break down that square root of 24. And I'm going to get minus 6 plus or minus 2 radical 6 over 2. If you don't get to this part right away, but you do have this part, your answer is still going to be pretty valid, right? This is all divisible by 2. I get minus 3 plus or minus the square root of 6. And I just divided everything by 2 because everything was divisible by 2. But like I said, if you get here, as long as you know where to place it on a graph, you're doing pretty good for yourself, right? So these are my two solutions for x. I have x equals minus 3 plus the square root of 6, and I have minus 3 minus the square root of 6. Make some sense? When I go to, well, I'll show you in a minute. Now we need to find our axis of symmetry, which we just need our AOS, which is minus b over 2a. Well, that's just minus 6 over 2 times 1, or negative 3, right? So we've got that part of the axis of symmetry already. To find our vertex, we know the x value is negative 3. We need to plug it in and find what the y value is. So we've got negative 3 squared plus 6 times negative 3 plus 3 equals y. So we have 9 minus 18 plus 3 equals y. 9 minus 18 is negative 9 plus 3 is negative 15. So that would be our y value. So we have all the information we need to graph now. So if I'm making a graph, I don't need anything perfect, like I said before, right? I've got I don't know why I'm making it so big, but it doesn't matter. Here I know that I have a point at, change the color. I have a point over here at what I'm going to call minus 3 minus the square root of 6, right? Minus 3 plus the square root of 6, still going to be on this side because the square root of 6, well, the square root of 6 would be 5, blah, blah, blah. I don't know what the square root of 6 is. I just need to know if it's more than or less than 3 so I know which side of the equation it's on. So I'm going to just check. Is 2.4 something. So it's still going to be on this side because it's less than 3. So we're going to say we have another point here at minus 3 plus the square root of 6. We also know that our vertex, our axis of symmetry, is going to be here somewhere in the middle of these two, where we are calling it minus 3, right? They're really like much closer to each other, but what do we know about this vertex that we have? We know that its point is going to be down here somewhere at like negative 15. All we need to know is that it's 3, negative 15. Don't need to be super accurate. Then I can connect my points. That is all I have to do, right? Use the quadratic formula to solve. Find your axis of symmetry in your vertex. Plug in those 3 points onto a graph and connect them, right? Any questions regarding that? Y'all are so quiet today. I don't know if you're sleeping on me or just catching up with the notes. Someone's got to give me a yes or no answer. Do you guys have any questions? Someone other than Alfonso, Gracie or Liliana, you have to give me a yes. There we go. Thank you. If you feel good about it, I'm going to skip my next example. It's just following the same, unless you guys want to see it, in which case I'm happy to keep going. But